Hi guys, this is a really brief reminder of function notation. This is a concept that you learned in first semester of Algebra 1. So what is function notation? Function notation is a way to represent evaluation of functions using a notation that lets you know quickly and easily what the input and the output of the function is. So for instance, we know that f of x, kind of like fancy y, it's a way of saying that the relationship we're looking at is a function, that for every input there's exactly one output, that the relationship passes the vertical line test. So for instance, if you were given the function notation statement f of -3 equals 5, that lets you know that when x is -3 on this particular function, y is 5. It also informs you of the fact that when x is -3, you will have a point up here at 5. So evaluate versus solving. These are two totally different verbs in algebra that oftentimes you'll hear kids use inappropriately. So evaluate means to find the value of a function for a given particular value. So for instance, you could evaluate f of x equals 10 minus x for x equals 2. You would just plug 2 in, and you would say, oh, when I evaluated for x equals 2, I got that f of 2 equals 8, the value of a function for a given value. In more advanced math, you can evaluate for expressions like f of x plus 2. So if we use that same function, f of x plus 2 would be 10 minus the quantity x plus 2, which is 10 minus x minus 2. 8 minus x. So that's evaluating. It's finding the value of a function at a point. Solving is something different. Solving is saying, if I have an expression like 2x plus 3 equals 15, can I solve for the value of x? And you would do this by subtracting 3 and dividing by 2. That's solving. Solving can become more advanced and have multiple different strategies to solve an equation. You could also solve for a given variable. So if I changed this up and I made it 2x plus 3y equals 15, I could solve for the value of y in terms of x. So I could subtract the 2x and divide by 3. So I have solved for y. Even though I don't know the exact value of y at a given point, I've still rewrote the expression to isolate the y. So let's talk about evaluating algebraically. So for all of these expressions, let's evaluate for f of, how about -5? So if we're given the expression something like f of x equals 20 minus 5x, we would simply plug in -5. And you'd say, oh, okay, well, -5 times -5 is 25. So f of -5 equals 45. But you could also do this with something more advanced, something like if you were given f of x equals, how about 6x over 10 minus x squared. You would still plug in that -5. You would substitute -5 in for x. And you would end up with -30 in the numerator. And you'd end up with, well, -5 squared is 25. So you'd end up with 10 minus 25. So you'd end up with -30 over negative 15, which is 2. So f of negative 5 equals 2. You can also evaluate graphically. So let's look at this function. Let's say I want to evaluate for f of 2, f of 0, and f of negative 3. So f of 2 is saying when x is 2, what's y? So in this graph, it is 0. When f is 0, well, y again is 0. But when x is negative 3, oh, y again is 0. So this has 3 zeros to this function. Let me get something more creative. How about f of negative 1? Okay, so f of negative 1, you would say, oh, that is 3. Over here, how about we evaluate for, we'll do f of 3, f of negative 3, f of 0, and f of 2. So f of 3, when x is 3, y is 3. When x is negative 3, y is negative 1. When x is 0, y is 1. And when x is 2, it looks like not an exact value. So you can use your slope in this case to help you out. You could say, oh, I'm going up 2. I have a rise of 2 with a run of 3. So that helps me know that my slope is 2/3. I'm going up 2 over 3. So that would help me know, oh, okay, this is 1 2/3. And then 2/3. If we go up another 2/3, that right here would be 2 1/3. So we can also use function notation looking at a table. We could say, okay, what is f of 7? So you look at the table and say, when x is 7, the function has a value of 16. Or when f is 20, the function has a value of negative 10.